looking at our second lesson in the new chapter that we started before break. So lesson 2 is going to be about electric current. So first, let's look at my planet diary here. My bubble will move. So it's about careers, and it says be a superconductor of science. So Jan van der Sande wants your city to run more efficiently. A company he co-founded is working to replace old power lines with materials that let electric current flow more efficiently. These materials are called superconductors. Superconductors are often found in lab equipment, as shown on the left, but companies like Van der Sande are finding other uses for them. Van der Sande didn't start his career working with power lines. He began his work in materials science as a professor at the Massachusetts Institute of Technology, or MIT. He got into superconducting by chance after hearing about discoveries at a lecture by one of his colleagues. He encourages everyone to stay open to opportunities in science because they can pop up anywhere at any time. So super cool there. What are our key questions for today? 1, how is electric current made? 2, how do conductors differ from insulators? And 3, what affects current flow? So first, when electric charges are made to flow through a material, they produce an electric current. An electric current is a continuous flow of electric charges through a material. Wow, that was a lot. Let me read that again. Electric current is a continuous flow of electric charges through a material. The unit for the rate of current is ampere, usually shortened to amp. An electric circuit is a complete, unbroken path that charges flow through. A conductor is material through which charge can flow easily. Insulators, I'm going to be all over the place today, are materials that do not allow charges to flow. So, the atoms in conductors have loosely bound electrons that can move freely. Electrons in insulators cannot move freely. And then our third, current flow is affected by the energy of the charges and the properties of the objects that the charges flow through. So we have our chart over here. We have a water current and an electric current. So in a water current is made up of moving water. Electric is made up of moving charges. In a water current, potential energy is converted into kinetic energy. In an electric current, potential energy is converted into heat and light. The energy source for the circuit of a water current is water. The energy source for the electric current is battery. So what's voltage? Voltage is a difference in electric potential energy per charge between 2 points in a circuit. So resistance is the measure of how difficult it is for charges to flow through an object. The unit of measure of resistance is the ohm, which we'll talk about a little more on Thursday. The 4 factors that determine the resistance of an object are diameter, so basically like how wide it is, length, material, and temperature. So what is our vocabulary? Electric current is a continuous flow of electric charges. Now that I double checked that, I apologize. So it should be a continuous flow of electric charges through a material. And I will make sure I fix that for next time. An electric circuit is a complete, unbroken path that charges flow through. A conductor, material through which charge can flow easily. Insulators, materials that do not allow charges to flow. Voltage, difference in electric potential energy per charge between 2 points in a circuit. And then resistance is the measure of how difficult it is for charges to flow through an object. Your assignment is to complete the Edmodo questions for lesson 2. If you have any questions, let me know.